Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be building an iFlight based freestyle copter. Now this isn't going to be my usual style of build video because there are some things that I'm in the unknown about. For example, I'm going to be using the iFlight KISS all-in-one flight controller. So they have licensed this from Flyduino and it's based on the KISS V1 flight controller, but it's also a power distribution board. It's got a built-in on-screen display, but there are going to be a couple of challenges because the on-screen display is programmable via a little board. In fact, I did an overview of this guy, so I'll put that in the below. But because I'm not going to be using KISS ESCs, you also need to use that controller board to program the ESCs. So I'm going to be using these iPeaka ESCs, which are a 32-bit 45 amp individual ESC. So we have got some low ESR capacitors there. And 32 bits is actually a little bit wasted on this flight controller because the KISS V1 only supports up to Dshot1200. However, the instructions recommend these ESCs. It's just that if you use KISS ESCs, then KISS ESCs use a serial number based system. So if you want to change the motor direction, then you can do it through the firmware. And I'm not sure if that's going to be easy to do, so that's where the unknown is. But I'm going to give it a go anyways because it looks fun. As for the frame, I've got two options, but I think I know which frame I'm going to use. So I've got the iFlight XL5 V3, but for me, freestyle these days is getting the props out of shot. And I'll overlay a picture of this guy, and you'll see that the arms come slightly further forward than where the camera will be sitting. So I think the frame that I'm going to use is going to be the HL5, and I'll also overlay a picture of that as well. It's quite odd looking, but the motors are going to be further back because of the style of arms. So I think I'm going to be using this because it's also got a GoPro mounting solution as well. As for the motors, I'm going to be trying the XING motors, and I'm going to go for the 2207 2450 kV motors. I wanted to use the purple ones, but I thought it'd be a bit garish, and all of the TPU parts on this frame are red, so these kind of match. As for the VTX, I'm going to be using the iFlight VTX 5804. I've used this in my cheap builds in previous videos and also on some of the hobby cool models as well, and it had really low noise. In fact, had no noise whatsoever when used with specific ESCs, and it switches up to 600 milliwatt. It uses an MMCX connector, and I really like it, and it fits as part of a stack as well. As for the receiver, I'm probably just going to use an XM Plus to keep it super simple. And as for the camera, iFlight actually do have their own camera, but I don't have it. So I thought I'd check out this FXT Mars Pro. It looks quite nice. Unfortunately though, it's not the right colour, but that doesn't matter. It's a mini camera, so it's 22mm across and uses an M12 lens, very similar to the Predator. So we've got a bunch of screws in there, loads of wires, but importantly we've got an adapter so that it can convert a mini camera to a full-size camera. So some of these things could be swapped out. It all depends how it goes. That's why it's not going to be a usual build video, because usually I know exactly what I'm doing, but we've got some things here where there are variables. So what I'm going to do is get on with the build, and if I run into any problems then I will flag it up, but it's hopefully going to make an interesting video. So let's take a look at the frame before I build it. So we've got a bunch of stickers, we have got the carbon fiber parts, so the top and the bottom plate and the side plate, and another piece there as well, which I'll have to figure out. Then we've got loads of battery straps in there, and we've also got 2 silicone mats so our battery doesn't slip. I really like that. Then we've got a TPU printed mount, which looks like it's to house your SMA connector for your VTX, and also 2 holes here as well, potentially for your receiver, so that's nice. Then we have got these arms here, which are very unusual but are hopefully going to get the props out of shot. By the way, I believe these TPU printed parts, and we've got more of them here, you can select them as an option so you don't necessarily get them. By the way, this is, I think, the V1 and there's a V2 now, so I just wanted to mention that. And I've got this GoPro mount here, and this is different than the one that you get now, but I'm sure it's all going to be fine. So yeah, we've got these landing pads here, which I tend to not use because they just get covered in mud here in the UK. And then we've got all of these standoffs and loads of screws, everything basically in one bag. I kind of don't like that. I wish they'd separate it out because there are no build instructions here. I think there is a diagram on the website, but it's always nice to have the screws separated out so you know where you stand. So there might be a little bit of guessing going on when it comes to which screw to use, but I can look at the website. So in contrast, I'll take a look at the XL5 V3 frame because they did send this to me, and maybe I will use it in a different build. So again, greeted with a bunch of stickers. We've got 2 battery straps, and they are the grippy kind. We've got a foam pad here, which I'm assuming is to stop your battery from slipping, but I prefer the silicone mats because with foam pads I've had batteries getting thrown before. They also can get ripped up and get quite tatty. However, with this being a fairly large Freestyle model and these battery straps being the grippy kind, that probably wouldn't be the case. The box is also smaller with this one as well, you might notice. And again, I think on the website you can select the TPU parts that you get, but looks like they've sent them to me. So we've got motor protectors here, and then not sure what this is for. Maybe that is for your XT60 or something like that. That definitely looks like SMA connector, and then maybe your antennas for your receiver, more motor protectors and more TPU parts and screws separated, that's a good thing. More TPU parts. Then we've got, oh, the frame is in its own sealed bag, so we've got the arms, and then looks like we've got a sandwich plate here, so top, bottom and a sandwich plate, and some landing feet, but again all of the screws and standoffs pretty much in one bag. That is my only complaint of both of these packages. So it's not as bad as it looked in the bag. We only have 2 different screw sizes. There are 18 M3 6mm screws and 16 M3 12mm screws. Then we have 8 M3 19mm standoffs, and then 3 M3 28mm standoffs. Now, Banggood's website says that there should be 8 M3 nylon nuts, but I only have 4. And it says that there are 8 M3 5mm and 6mm nylon spacers. Now the worrying thing is that the website also says that there should be 8 M3 press nuts, and I don't have those. And when I look at the diagram on the website, there's also a carbon spacer which lifts the height of the top plate, and I don't seem to have that either. So I think I've got a really early version of this frame, and I'm hoping that everything is going to fit. It should, because I'm going to be mounting the ESCs on the arms, but that is my biggest concern at the moment. So I've started to build up the frame, and it's actually very easy to build. So we have the longer screws that you get in the package, and those go underneath and then through the arms, and then we have the shorter standoffs, and that is the case for here as well, but I haven't put those on yet because I'm going to put my flight controller on there, and I'm going to be doing some soldering, and I think those might get in the way, so same there as well. But I've put these two standoffs in here, and these are the 6mm screws, so the shorter screws, and also the standoffs with the longer screw up the top here, because the flight controller, when it goes on, it's got more components than the VTX. So the VTX on one side has no components whatsoever, so I've gone for the longer threads on here, because we have these standoffs here which have a shorter thread for whatever goes on top, which of course is going to be the VTX. Then I've assembled the camera pod, and this is definitely a different version, of course, as I mentioned. So we've got sort of a cutout here, and this looks completely different now. Also, I don't think there is a top part anymore, it's just flat, and actually the top part doesn't actually quite fit properly. It's a little bit short, but that's not too much of a problem, I guess. The camera has gone in fine, and I just have left the standoff out here up the top so that I can still access the camera when I come to plug all of that in. I've put the motors on, and I've also used the TPU as well. Now luckily these XING or XING motors, they have already got thread lock on them. Now you can see that there is sort of like an indentation on the screws for the motors, and you have to do that, but that's fine, like I say, because it has got Loctite or thread lock, whatever you want to call it. And I was thinking as well, this is the way that you mount them, and I would recommend that you do get these, because it's a really strange design here, and you can actually bend this part of the carbon. I guess it's designed to collapse, but this is definitely gonna help to stop that. So yeah, you can actually flip them the other way around, and if you're having vibration issues, you could use them as soft mounts, I guess. So I'm putting the flight controller on next. So the issue that I'm seeing at the moment, it's not a huge issue, but it sits this way, and this is a Freestyle copter, and I'm actually quite surprised, because most KISS builds are Freestyle copters, and usually the battery terminal would come out of the side, but it's going to have to come out of the back here so that I can access the USB and also the connector for the on-screen display. So the next things to do is to cut the wires short and install the iPeaka ESCs, and also solder them up to the power distribution board. So I'm gonna crack on with that and see how I get on. So as you can see, I've moved on a little bit. So I've soldered in the iPeaka 45 amp ESCs, and I've also soldered in the low ESR capacitors as well. There is enough room in this frame for that, and there were no issues there. And I've soldered everything up, it's just got to go back together, and of course I need to wrap the ESCs in some electrical tape and hold those down. But I thought I would show you it in its current state and what I've had to do in order to get things working. So I'll just lift the VTX up so that you can see all of the connections. So we have got both the positive and the negative wires going to the solder pads. It's all a little bit crammed in there, but it does just about fit. Then we've got the signal wire, which is the yellow wire, and then the telemetry wire, which is the black wire, and that is the case for all of them, and they all turn anti-clockwise like that. So one of my concerns was changing the direction of the motors. Now they do provide you with this little board here, and the idea is that you plug this into the flight controller and then you can get a BL-HALI-32 pass-through. However, I could not get that to work, just as I suspected, because KISS uses a serial based system and it blocks that. So if you do want to change anything in BL-HALI-32, you are going to have to do what they have done here with the diagram. So you'd have to desolder the signal and possibly the telemetry wire, and then somehow get them connected to this board with the jumper connected. Now, luckily, you do not have to do that if all you want to do is change the motor direction. So what you can do in the KISS firmware is you can actually plug the battery in and then plug in the USB, and you can still change the motor direction. It recognizes the ESCs, and with them all connected up like this, I had to change this motor and this motor, and that was really easy to do. So as for the other connections, we've got the VTX and camera. So it's quite tricky to see, but we've got the video out there for the VTX and then the video in for the camera, and the camera is also running off a 5V there, but then the VTX is powered from VBAT, so that's this red wire here. It's very difficult to see, and then next to that we have got a ground wire for this, and then smart audio is there, so that is all soldered up. And then the receiver, I'm using the XM Plus, which I have flashed the version of the firmware with the RSSI on channel 8. That's important because KISS only recognizes up to AUX 4 for RSSI. That's KISS on-screen display, I should say. So we have got the ground there, the signal there, and then also the 5V out. I've managed to mount the receiver at the back, and I'm also going to be able to use this TPU mount. Maybe I'll use some cable ties and some heat shrink for that, so that's quite nice. I haven't installed a low ESR capacitor on the battery cable because the ESCs have got them individually. I thought I'd try a Unify because they can run off 5V, and I got so much noise from the Unify. I'm not sure what's happening there. Maybe the regulator just produces quite a lot of noise through this system, but I made sure everything was connected up correctly. So this is going straight from the VBAT, as I mentioned. The camera did require to have its on-screen display turned off, but that's easy because the connector is part of the harness. So I just went in there and switched that off. And I've also installed this top brace. This piece of carbon here, I'm guessing this is a prototype because it doesn't fit, and when this brace is in place here, it just falls out. So it's not going to be of any use. But a GoPro is going to sit on there, and I've noticed as well the style of GoPro mount is very different to the one that they have now. And I tested it and I was getting a little bit of red in the corners, so what I've done is I've taken some cutters and cut away some of the TPU, and I don't seem to be getting any red in there anymore. I think the idea of this is to just stop any vibrations from coming through, and of course we've got a piece here for a strap to go through, so that can go underneath there, and I think it's actually going to get some nice shots if it flies nice. But all that is left to do now is put this back together. One thing that I did struggle with is what to do with the XT60 connector. Now, because this is a large area, I decided that the XT60 could actually go through these two holes here. There's not really any friction there, and the battery fits on there no problem up to a 1800 with the GoPro sat on there, so I thought I would have it coming through there. Other than that, I guess you could have it coming out of the side and cable tie it to here, but it would move about, so I've decided to put that up there. So all that's left to do, as I say, is put these other standoffs in place, tidy everything up, and then we can go into the software and take a look at that. So for KISS on-screen display, we are going to be using this lead here, which connects into the side, and also we don't want this jumper, but I'm pleased to say that it's pretty easy to use, so I'll take you through that as well. So here is the finished model, and it went together really nicely. I wrapped the ESCs in electrical tape and then used electrical tape again to secure them to the arms. I fitted the standoffs at the back and also the front, and then secured the top plate on, which fits flush really nicely. I used their battery straps, which are grippy, and they have got a slot for the battery straps to go through. But I also used their silicone mat, which is really too long. So what I did was I wanted to use all of it because I want my battery to sit as close to the GoPro as possible. So I cut some of it out because these screws got in the way, and the screws do not protrude above the silicone mat. So as I say, I can use up to an 1800 4S battery, which is nice, even though the XT60 is here. I didn't want the XT60 to run out of the back because I found that you can get interference through the VTX from the XT60. We learnt that with the Eachine Wizard X220 HV, but there was no other option really. I suppose I could have it coming out of the side, but these are elongated here for the slots, so I didn't want it to get too close to the prop, so that seems to work. Then I used their GoPro mount up the front, and as I say, I had to cut some of the corners out because red was showing in super view. And I've used their strap as well to secure the GoPro down. My only complaint is that the strap covers the button, but I can still press it and I can still see the screen. And as I say, if you look at pictures of it now, they have changed it even more. I believe it has got two parts that come down here to stop it from moving, but this was moving a little bit, so these parts that I cut out here I actually reused and put them across the carbon here, and the GoPro no longer moves, and I didn't use the little carbon plate because it would just fall out. But that should give an extra little bit of vibration dampening, as well as keeping it in place because it is silicone, so it doesn't move around. Then at the back we've got the TPU mount, and I've used some straws. These are some spare ones that came with a GEP RC product, and the XM Plus antenna is just running up there really nicely, and I've cut those to length. And then the propellers, I'm starting off with low pitch. I always do this with builds because I'm never sure how it's going to react. So these are the Dal 5040, and then if there isn't enough power there, I can start to up the pitch. But I always start off with low pitch just in case the system can't deal with the current. I mean, they should do because they are 45 amp ESCs, but it's a good place to start. For example, I'm still using these propellers on the Skystars Star-Lord, which is my current favorite freestyle model. And you might be thinking, this looks very heavy, but it's actually not too bad. It's 482 grams, and as I've explained in other videos about the differences in freestyle and race copters, is weight is a good thing for a freestyle copter because it cuts through the air better and you get smoother video footage, whereas a race copter is light and you can get prop wash oscillations. It's kind of like a brick flying through the air rather than a feather, which is going to get more affected by the air. It's going to be the feather, obviously. And one thing I do like is that the camera is really far forward. So if I compare it to the Skystars, you can see that the GoPro sits forward, so I don't think I'm going to get props in shot. I don't get props in shot with this guy anyways, so that's a good thing. The only other thing that I noticed is we have got this bar at the bottom here. I guess it's the only way that they could have secured the side plates without getting in the way of the camera. Now they do provide foam feet, but it's really muddy here, so I've not used them. But if you were to land on concrete, then I can see that breaking. But as I say, I think that's why they provide the foam feet. So maybe if I'm ever flying off concrete, then I will add them. But the Skystars Star-Lord weighs 470 grams, so that is both with GoPros, so it's actually only 12 grams lighter, so it's actually not too bad weight-wise for a freestyle copter. Now, it was originally my plan to get everything wrapped up in one video, but we're already approaching the 30-minute mark, and I really don't like to do this, but I'm going to make this a multi-part mini-series, because with everything that I have learnt from this, the video would be about an hour and a half long, and I think that's too long for someone who might be casually interested in this. But at the same time, I've done all of the setup and flown this thing, and I think there is a lot of merit in this model. So in part 2 I'll show you how to flash and set up the latest version of KISS and change the motor direction without having to mess about, and that's also going to help people with the original KISS V1 boards as well, but using non-KISS ESCs because KISS ESCs are very expensive. Then in part 3 I will go through how to flash and set up KISS on-screen display, which I don't think anybody has really done fully, and I found that it's really powerful and really awesome. And then part 4 will be the flights, where I do a line of sight flight and also FPV. So if you are interested, I will link to all of the parts of the build in the description of this video, and I will see you in part 2. And of course, I'll make a playlist once all of the parts are uploaded, then you can binge watch every part if you like. But until then, thanks so much for watching. Please continue to subscribe. Cheers.